Hello friend, welcome you again. This is fifth part of the tutorial series bulk RNA-Seq data analysis, and in this part I'm going to show you adapter trimming using the package Trimmomatic. So let's start. But before going through the Trimmomatic option, I'm going to show you the QC report from the SortMe RNA FastQ file. Already remove the rRNA from the raw FastQ file, and if you open any FastQC report, you can see the basic statics sequence length 101 base and the adapter content. If you select this, you can see here adapter is present and the name is Nextera transphase sequence. So after removing the rRNA, the still adapter is present in the FastQ file. So in this part I'm going to show you how you can trim this adapter. Now I'm going to open my terminal sudo su. I'm going to change the directory RNA-Seq. I'm going to activate the Conda environment. So RNA-Seq demo Conda environment is active, and I'm going to open a new window so that I can show you the script. Sudo su. I'm changing the directory Conda activate RNA-Seq demo, the environment that I'm using for the bulk RNA-Seq data analysis, and I'm going to open the script here. I have already written the script for the Trimmomatic. You can see at the step 8 trimming of adapter, and here in the terminal if you type Trimmomatic space -h, you will find the command for trimming the adapter pair in and for the single end, and you can use this to trim your adapter. And here I'm showing you for my case Java jar and the file path for the file trimmomatic.jar. So how you can get this path in your case? For this, if you perform the ls command root miniconda environment and then your environment name RNA-Seq demo in my case, but it will be different in your case, and then share folder or directory. In the share, if you press enter, you can see Trimmomatic and Trimmomatic 0.39-2 directory is available, and if you go through this directory, you can see there is a file trimmomatic.jar that we have assigned here. So you don't have to confuse, you have to just provide the path. Next is PE, denoting the parent FastQ file, and the path for the input FastQ file read1, SortMe RNA read1 file, and the read2 file. So I'm using the rRNA free that we generated using the package SortMe RNA. So I am using these FastQ file read1 and read2 as an input for trimming the adapter, and next output for the trimming. So and the directory I am using the Trimmomatic to save the trimmed FastQ file using the name SortMe RNA Trimmomatic R1 and the unpaired FastQ file. Like this for the read2. So I have to make the directory Trimmomatic so that I can save this file in that particular directory. For this I'm using the mkdir space Trimmomatic, press enter, and the next is Illumina clip, and the path here you can see the adapter, and the adapter name is Nextera pe-pe.fa. So you have to use according to your adapter present in your RNA-Seq data. Like if you select the adapter in the FastQC report, you can see the adapter content present in your FastQ file. In this case, Nextera transphase sequence. That's why I selected the Nextera. But for the path and the adapter name, how you will find? So for this, I'm using the ls command root miniconda environment RNA-Seq demo share Trimmomatic adapter, and if you press enter, here you can see the adapter sequence present in this folder. So you have to use according to your adapter content. So in my case, Nextera PE, so I'm using the path and the Nextera PE.fa adapter file, and the next is 3, 30 and 10, and these are the Trimmomatic option specifying adapter sequence to be removed. 3 is seed mismatch value, and 30 is palindromic clip threshold, and 10 is simple clip threshold. And the slide window, slide window is a Trimmomatic option specifying the sliding window trimming parameters. This trims the read once the average quality within the window falls below 20, and then scan the read with a 5 base wide window, cutting when the average quality per base drops below 20. And the min length 50 is a Trimmomatic option specifying the minimum length a read must be to be kept. Reads shorter than 50 bases after trimming are discarded. So I'm going to save this script, and here I'm going to run the script RNA-Seq demo. Here you can see it automatically detects the thread value for this FASTQ file, that is thread 33. So adapter trimming is complete, and you can see the file short me RNA Trimmomatic R1 and R2, and I'm not going to show you for all the file. I'm going to check the FastQC to confirm the adapter trimming. So I'm just putting the hash so that I can stop the script to run again. And step 9, here you can see I have already written the script for the FastQC. I'm just going to remove the hash so that I can activate the script FastQC thread 32 output Trimmomatic QC. So I have to make the directory Trimmomatic underscore QC. For this, mkdir Trimmomatic underscore QC. So directory is created. I'm going to save the script, Control O, enter, and run the script in this window. Press enter. So FastQC report is generated for the read 1 and read 2, and I'm going to open this. And now if you select the adapter, you can see adapter is trimmed from the FASTQ file. And if you check the basic statics report, the length is 50 to 101 base. So in this way you can trim the adapter from your RNA-Seq data using the package Trimmomatic. And if you are facing any problem in running the script for the Trimmomatic, please let me know. I will try to help you as soon as possible, and I hope this tutorial may help you in the journey of RNA-Seq data analysis. And thank you for watching my video. If you like the video, please subscribe my channel. Thank you.